So this is Chapter 10b, Factors and Levels. So let's just look at some synonyms. There's a lot of language in this chapter. So first off, factors are these nominal variables, usually nominal, forming the categories across which the dependent variable is compared. So we'll use the word factors here, but they do include independent variables. And independent variables, that's a term we use to describe variables that are assigned or manipulated by a researcher. And so some factors are independent variables, but not all. And sometimes in these slides or in your reading, you'll just see these listed as variables. That's also accurate and true. They are variables. And then levels is a word that's commonly used to represent the different conditions within factors. And that might seem like a strange word to use, but it stems back from medical trials in which the different levels of a medication or treatment might be given, like low dose, medium dose, high dose. So that's where levels comes from. But we can also use conditions, and sometimes that's a more appropriate word. And we could also use categories. And how many factors can we use? Well, in a factorial ANOVA, we can have, as many, we could have many factors. But for every additional factor, you have to have more participants because, remember, we have to meet those laws for normality, and we can't meet those. Each one of those, the more factors we add, the more possible combinations there are, and the more we would need in our study. So usually in psychology, 2 or 3 factors would be typical. So here's our two-way ANOVA. Again, way just means factor. Let's imagine this example. A marketing specialist wanted to compare clothing cleanliness across detergent type and water temperature. So 2 factors in there. We have factor 1, water temperature, and that factor has 3 levels, cold versus warm versus hot. Again, conditions is another word we could use here. Factor 2 is detergent type with 2 levels, detergent X and detergent Y. And we can see in the first level, in the first factor, we could see levels being an appropriate word because we have a gradation. We do have different levels of water temperature. But in this second factor, a better word might be condition, because detergent X and detergent Y are not levels of anything. So, the language can get kind of muddy, so just know that these words are used interchangeably. Over in the grid here, we can see this is laid out with the 3x2 conditions. And in here, normally we would calculate means, but these are the raw scores. So, the first detergent X in cold water, the cleanliness level was 4, 5, 6, 6, 5. So that's just the raw data. And so we would call this a two-way because we have 2 factors. 3x2 ANOVA, we could say 2x3. In this case, we won't worry about that just now. And we have 6 possible combinations. We could have detergent X with cold water, detergent X with warm water, detergent X with hot, and then we could have detergent Y with cold, Y with warm, and Y with hot. So we notice that if we take 2x3 or 3x2 and multiply those numbers together, we get this 6. And so we call it a 2x3 or 3x2 ANOVA with these combinations. We can have a 3-factor ANOVA. We would call it a 3-way ANOVA. And 3 variables we would call factors. So we could have gender as factor 1, medication as factor 2, factor 3 could be dosage. We can see that we lay this out on a 3-dimensional. We can no longer lay it out in that flat square grid because we're now multiplying these 3 variables. So we might have to have male, female on this vertical axis, treatment control condition on this horizontal axis, and the depth axis might have high dose and low dose. So each factor has 2 levels. So our 3 factors are listed here. Each has 2 levels, gender, male versus female, medication, treatment versus control, and dosage, high versus low. We would call this a 2x2x2 factorial ANOVA. And that's because we have 2 levels under gender, 2 under medication, and 2 under dosage, which means that if we multiply those together, 2 times 2 times 2, we find that we have 8 possible combinations. Like we could have male treatment with a high dose, male treated with a low dose, male control high dose, male control low dose. Doesn't make that much sense actually. And we can have female treated with a high dose, and so forth with those other conditions. So the X's in there kind of makes sense. We usually do read it as 2 by 2 by 2, with this idea of this dimensional model in mind. So let's go through some designs. So our first example, an optometrist wanted to compare satisfaction with eyeglasses across 3 conditions: uncorrected far vision, and he's got strong versus moderate versus weak; uncorrected near vision, strong versus moderate versus weak; and type of lens, single vision, bifocal, progressive, monovision. So just to lay this out, our dependent variable is satisfaction with eyeglasses. Factor 1 is uncorrected far vision, and we have these 3 levels. Factor 2 is uncorrected near vision with 3 levels. Factor 3 is lens type with 4 levels: single vision, bifocal, progressive, and monovision. So what we have here is a 3-way, because of these 3 factors, 3 by 3 by 4 ANOVA, and that's because we have 3 conditions here, 3 conditions here, and 4 conditions here. So when you see these little 3 by 3 by 4, those are just referring to the levels within each factor. And if we multiply this together, we would find that we have 3 times 3, 9 times 4, 36 possible combinations here. And if he's going to have 30 people in each condition, or even 10 people in each condition, that's a lot of people in the study, which is why we tend to limit the number of conditions we text. Another example. A psychologist wanted to measure relationship harmony after randomly assigning couples to one of 2 response conditions the next time they felt they had been misunderstood by their partner. So they could explain themselves A, immediately, B, 4+ hours later, or C, never. So just 3 conditions there. And she also wanted to know whether this harmony differed between husbands and wives. And so we can think of our DV as relationship harmony. That's what we're measuring. Factor 1 is spouse gender with 2 levels, husbands versus wives. And factor 2 is the response to being misunderstood with 3 levels, immediately versus 4 hours later versus never. So you probably can already guess that this is going to be a 2-way, because we have these 2 factors, 2 by 3 ANOVA, and with 6 possible combinations. We could have a husband who's told to respond immediately, a husband who's told to respond 4 hours later or more, and a husband who's told to respond never, and the same true for wives. So our 6 possible combinations. Example 3. An organizational psychologist wanted to know whether dim or bright lighting and slow, moderate, or fast tempo music would impact the number of correct responses students made on a proofreading task. So our dependent variable is task accuracy. Factor 1 is lighting with 2 levels, dim versus bright. Factor 2 is music tempo with 3 levels, fast versus moderate versus slow. And whoops. Example 4, what design structure? A researcher wanted to compare symptom relief in male versus female patients on high, medium, and low doses of 3 different herbs. The dependent variable is symptom relief. Our factor 1 is gender, male versus female. And by the way, I'll just comment on this briefly. When researchers limit it to male and female, even though we do have acknowledgement generally that we have more genders than just male versus female, the problem arises because there are relatively few people who are non-binary identifying, and you just can't run a statistical study with small n's. And so people aren't excluded from studies because they're not seen to be valuable or valid. It's because it's hard to get enough people to represent a small minority category like that. And so just in terms of the mathematics, it can't be done. So that's why it's excluded. It's not any intention to limit the number of people. And there might be another study where it's studied in non-binary people. And so then factor 2 is dosage, 3 levels, high, medium, and low. Factor 3 is the type of herb, herb 1, herb 2, herb 3. You can see these things aren't necessarily listed, you know. Like, for example, this word gender, naming this factor wasn't listed, but yet we infer this because we're comparing male and female. Dosage wasn't listed here, so we're naming the variables here. And herb, you know, we said 3 different herbs, but they weren't specified. So you have to draw a little bit of inference as you name the variables that are capturing certain categories. And so this is a 2 by 3 by 3 ANOVA, and it's also a 3-way ANOVA because we have 3 factors. Of course, we would have 18 possible combinations if we ran a study like this. Last example, example 5. A researcher wanted to compare self-reported confidence on easy versus difficult tasks in males and females according to whether they received positive, neutral, or negative feedback. Once again, you're seeing that the variables aren't specifically named. The conditions are named, so you have to infer the variables from this description. So the dependent variable is confidence, stated easily. Factor 1 is gender, and once again we have these 2 male and female identified for reasons I talked about in the previous lecture. And then task difficulty, easy versus difficult, 2 levels, and feedback, 3 levels, positive, neutral, and negative. So we would call, once again, I named the variables. They weren't explicated clearly. And we would see we have a 3-way ANOVA because we have the 3 factors, and it's a 2 by 2 by 3 ANOVA because of the numbers of levels within each factor. And so that captures that work. So a little bit about the practice quiz, and this also might be on the actual quiz. So what you're going to be doing is you're given a short description of a study in the fill-in-the-blank sentence, like the one we just went through, the scenario in which a researcher wanted to compare self-reported confidence on easy versus difficult tasks in males and females according to whether they received positive, neutral, or negative feedback. So the sentence you'll get that you'll have to complete by writing your answers in is, this study has blank factors in a blank design with blank possible combinations. This is what the answer should look like. It should be, you would fill in the digit 2 for the first answer. For the second answer, you would write 2 by 2 by 3. And for the third answer, you'd write 12 possible combinations. So some tips: just use digits. Don't write these out in words. Don't use spaces. I've tried to accommodate different ways you might write your answer, but it's best if you just, write them the way, don't use spaces. And list the levels in the order they appear in the problem. And by that I mean, when you're listing a 2 by 2 by 3 design, well, that's because that's the way it was in the problem. We had the 2 variables, easy, difficult, the 2 levels, and then we had another 2, males and females, and then we had the 3, positive, neutral, or negative. So this is a little bit different. I couldn't think of another really good way to put together practice on this, so do this lots of times. I think it'll help you understand the kind of logic of ANOVA. So with that, you should be ready to take your practice quiz.